Hi guys, welcome back. We're going to talk about compound inequalities today. Inequalities are when we're comparing a number and it goes in two different directions. So it might be between two numbers, okay? So a lot of times a compound inequality will look something like this. And again, we have two inequalities. So I'm going to go ahead and draw my dotted line through both sides of my inequality, okay? And my goal is still to get n by itself. So I need to get rid of this 9. And again, 9 is being added to n, so we're going to go ahead and subtract 9 from the center. But we also then need to subtract it from the left and the right-hand side, okay, to keep it balanced. So -1 minus 9 would be -10. And I didn't divide by anything negative or multiply by anything negative, so my inequality stays. This cancels, leaving me with n. And then 17 minus 9 would be 8. Okay, so my n is between -10 and 8. And then, of course, as we do with all inequalities, we're going to go ahead and graph that. So when we're doing a compound inequality, we can just write our two numbers. Okay, and since at -10 we have a less than sign, and then at an 8 we also have a less than sign, we're going to go ahead and do two open circles. And this says n is bigger than -10, so it's going to go here. And n is less than 8, so we're going to go this direction. So since the arrows are pointing towards the middle, we can highlight the middle. So sometimes we might have an inequality graph that goes outwards, and sometimes we might have one that goes inwards. Okay, so just be prepared for that. You want to test that and make sure that that works out before you just assume that it's in the middle. Okay. All right, let's try another one. Okay, so I'm just going to rewrite this so it's a little neater. So this would really be p over 2 is greater than 0. So again, I'm going to go ahead and draw my dotted lines. That helps a lot of you kind of stay organized. So I'm going to say what's stopping p from being by itself, and that would be the 2. And I'm going to multiply both sides by 2 since it's being added by 2. And I didn't multiply by a negative, so I don't have to worry about flipping my signs. But if I did multiply by a negative, I'd have to flip both of the inequalities. 2 times -3 is -6, is less than p, which is less than 0. So again, I'm going to go ahead and draw my graph. And again, when we have just the two numbers, we can go ahead and place both of those on the graph. Okay. And -6 has an open dot and 0 has an open dot. And p is greater than -6. So we've got numbers going this way. And p is less than 0. So they're going to go ahead and go this way. So it will, in fact, be in the middle. So I could choose any number between -6 and 0, and that would make this statement true. If I chose something outside like -7, that would make the statement untrue. All right, let's try a two-step one. Okay, I'm going to draw my lines. So again, I always get rid of addition, subtraction first. So I'm going to subtract 6. And again, I do it on every side, not just one of them. So -50 minus 6 would be -56 is less than 7x, which is less than -14. We're going to go ahead and divide by 7 on every single side here. So we're going to get -8 is less than x, which is less than -2. And again, we're going to go ahead and draw that. Okay, so we have -8 and -2, and they both have open circles today. And x is bigger than -8 and less than -2, so therefore we're going to highlight in the middle. Okay, all right, get another one here. Now this one's a little different. This is an or statement. These ones are and statements because it has to be between -8 and -2. So an or statement, we have two separate things, and we're going to solve for a on both of them. So I'm going to add 4 to this side. So I get a is greater than, I can't write today, sorry guys. A is greater than 5. Or we're going to add 4 to both sides here. We get a is less than 1. So again, we're going to do 1 and 5 on our graph here. And they are, in fact, both open circles. So I need a is greater than 5, which means I'm going this way. And a is less than 1, so we're going this way. So an or inequality, we'll have our arrows pointing outward. So it's either less than 1 or less than 5. That's why it's an or statement, because if I'm less than 1, like at 0, I'm not also greater than 5. But if we look at an and statement, I can be between -8 and -2 by choosing, say, -6. So these are what we call and statements, while these are or statements, because it has to be either or. All right, let's switch to the next one. So I'm going to write an inequality, and I want you to, or I'm going to draw the graph, and I want you to try and write the inequality for me. So if we have a graph like this, so that's going to be my closed dot, this will be my open dot. Can you write me an inequality for that? So I know that there's some number between these two numbers, so I'm going to call that x. And I would say x is bigger than -8 or equal to -8 because it's a closed dot, and less than 6. Okay, let's go ahead and try one more. Let's say we have -5 and 3. And we're going to have a closed dot over the 3 and an open dot over the 5. Go ahead and write out a statement for me. Oh, and there's between, sorry guys. So this would be x is greater than -5, but less than 3, or equal to 3. Okay, I hope this video finds you well. Good luck, and we'll talk to you tomorrow. Bye.